Hi, I'm Loretta. My topic is speech disorders, and I'm going to present the neuropsychology pillar. The title of the article is Atypical Callosal Morphology in Children with Speech Sound Disorder. I would like to begin with how we produce speech sounds. It requires two elements. One is knowing about the speech sounds, and the other is the ability to coordinate our oral motor components, including the jaw and lips, as well as coordinating our breathing and voicing. Speech sounds disorder is a pervasive speech disorder or speech production deficit that has no well-defined neurological lesion or known cause. It occurs in 3 to 5% of preschool children, in which some would grow out of it, while some would demonstrate persistent symptoms, including difficulty with speech sound production, misarticulating their speech, with poor intelligibility. Although there is no known explicit pathways of speech sounds disorders, there might be some possible explanations of speech sounds disorder. From the neurobiological perspective, corpus callosum connects our right and left hemispheres through many neural fibers. And as we may know, our left hemisphere is responsible for receptive and expressive language. And the corpus callosum helps to modulate our hemispheric specialization, which means the language dominance. Therefore, it seems to be a plausible brain structure when exploring the underlying anatomical substrates of SSD. And children who have speech sounds disorders might demonstrate abnormalities of interhemispheric communication channels or aberrations of cerebral commissures. There were limited imaging studies examining the structural and functional correlates of speech sounds disorders as well as speech pathologies. In fact, there was only one study noting abnormality of the corpus callosum in speech sounds disorders. For more information, thinner corpus callosum represents fewer axons, and studies show that smaller callosal dimensions suggested decreased interhemispheric connectivity and signal conduction in speech-related channels. Therefore, we are wondering if impaired interhemispheric signal conduction would lead to atypical lateralization of speech function and speech disorders. This study will therefore investigate the corpus callosum thickness in children with speech sounds disorders and compare it with typically developing children. Two hypotheses were generated. The first, there would be significant deviations in callosal morphology in children with SSD. Second hypothesis, there would be reduced aberrations of callosal thickness in children with SSD. To investigate, there will be two groups of children between 9 to 11 years old. Brain scans were performed to compare the callosal thickness of children with SSD and the age-matched control, which means speech sounds disorder diagnosis was the independent variable, while the callosal thickness was the dependent variable. A general linear model was used to assess the differences in callosal thickness. Since intracranial volume increases with age, these variances were also removed by technical methods. Results suggested that the corpus callosum in children with speech sounds disorders were significantly thinner compared to their typically developing counterparts. Especially within the anterior one-third of the corpus callosum, mainly the rostral body. For the discussion, speech sounds disorders is accompanied by regional aberrations in callosal morphology, including reduced thickness and volumetric contractions. However, these results contrast with previous studies in which affected children had greater white matter volumes instead of more smaller volumes compared with the typically developing children. But spatial location was in agreement with other studies, and there were significant links between anterior third of the corpus callosum and speech functions. That means this finding seems to resonate other studies that proposed corpus callosum involvement in speech disorders. To conclude, this study supports both hypotheses, which means there were significant deviations in callosal morphology in children with SSD, as well as there were reduced aberrations of callosal thickness in children with SSD. In terms of the strains, this study used straight selection criteria in which children performed prior study had to undergo standardized speech tests to rule out language disorders which do not necessarily have, to rule out children who might have language disorder but who do not necessarily have speech disorders. And intracranial volume increases with age. Therefore, the effect of age and total intracranial volume was also considered. This study specifically focused on callosal thickness and other neural pathways were eliminated using technical methods. In terms of the limitations, there were only 18 people in each group, so it was a small scale of study with a small sample size. Studies also show that boys had a higher likelihood of speech sounds disorders than girls, but therefore gender effects should be considered, but it was not discussed in this study. And left hemisphere is responsible for speech and language. It dominates our right side of the body. However, the effects of handedness were not discussed either. And there was no information about any previous speech interventions for the group of children who have speech sounds disorder. And recent studies also show that people with music training have better interhemispheric connectivity, and this study did not investigate whether the children had any music background or music training. Therefore, further research could be repeated using a larger scale and of more participants and also different age groups, apart from just 9 to 11 years old. An fMRI could also be performed to investigate the speech functions apart from simply structural imaging. For example, asking the children to perform some speech-related tasks while doing the brain scan. And also, the corpus callosum thickness of children with different cultural and language backgrounds could also be studied so that there will be investigations of cultural differences and also monolingual versus multilingual environments. And lastly, we should also try to investigate the music training background of children while doing further research. For the applications, these might include using it as a diagnostic battery to assess the difficult-to-test children who may not comply to standardized speech tests easily. And it can be used as a prevention method to predict persistent SSD and as an outcome measure to counsel parents about why the children might have these kind of disorders. And here are the references. And thank you very much for listening to my presentation.
Hi, my name is Zoe, and today I would like to dissect an article written by Waltz, Peach and Miller entitled A South Korea Impact Profile, Development of a Scale to Measure Psychosocial Effects. I'll be focusing on the topic of a speech disorder and presenting from a clinical psychology perspective. I'll address the background, introduction, methodology, results, discussion, strengths and limitations and conclusions, and finally future implications outlined in this paper. The speech disorder addressed in this paper is dysarthria. Dysarthria is an acquired speech disorder that affects the articulation of speech. It occurs when brain damage causes muscles used in the production of speech to weaken. Dysarthria is characterized by speech that may be slurred, mumbled, slow, too fast or too soft, jagged, or exhibits changes in pitch. In the clinical treatment of dysarthria, the authors mention that clinicians are encouraged by the World Health Organization to take a holistic approach to evaluation and treatment. With specific reference to acquired dysarthria, it is argued that the availability of a comprehensive range of tools to assess social functions lag behind other speech disorders. Therefore, the authors developed a dysarthria impact profile, herein referred to as the DIP, to assess the psychosocial impact, that being the psychological and social consequences of dysarthria that can directly affect social participation. The current paper was written by the authors with the aim to investigate the psychometric properties of the DIP. No hypotheses were reported. The authors note that the methodology for the development of the DIP involved 3 phases. However, the current paper solely reports the aim and results of the 3rd phase. Therefore, I will discuss the method involved in this 3rd phase. The first step involved in this phase was to screen 48 potential participants with subtests for head injury using the HISD2, aphasia, and cognitive impairment. Participants were of Irish citizenship and recruited via theoretical sampling. Participants had a range of ages and dysarthria severity levels. The authors deliberately sought participants whose therapists believe were aware of their dysarthria, yet were not concerned about it. Following subtest results, 31 participants were then included in the Phase 3 study. Participants then completed the DIP in their own homes or in a hospital. It was not mandatory for the DIP to be completed alone, and assistance was granted for participants who required it. Answers to 48 statements on the 5 scales of the DIP were rated on 5-point scales, ranged from strongly agree to strongly disagree, as seen in the table presented. Once data was collected from participants, several data analyses took place to analyse psychometrics. The authors did not explicitly state the methodology nor process involved in this stage of the study. However, the authors did note that it involved assessing the psychometric constructs of reliability and reliability. Defined, validity refers to how well the DIP measures the concept of psychosocial impact of dysarthria. Reliability refers to the consistency of what the DIP measures. The authors assessed construct and content validity, convergent validity using a Wilcoxon-Ranks test, concurrent validity by comparing results to the HISD2, and intra-rater reliability using a Pearson's correlation. The authors reported several significant results from data analysis regarding reliability and validity. Internal consistency was supported by Cronbach alpha values of 0.8 and greater. Intra-rater reliability was supported for all sections of the DIP with an R of 0.6 and greater. Convergent validity was supported with an R of 0.683 on scores between the DPI and the HISD2. However, this was only for section A of the DPI. For significance, the p-values were set at the 0.01 level. This is to show that results were not due to chance. Following a report of largely positive results, the authors then continued to a very limited discussion section. Here, results were not analysed or discussed and only 2 main points were addressed. The first point mentioned was that the DIP may be suitable for research, however not yet for clinical application. The second point entails a requirement for further development and refinement of the DIP to be suitable for clinical application. However, this point may be applicable for research use also. Before I divulge into the limitations of the current paper, I would like to mention some strengths. The recruitment process ensured that participants were describing the speech disorder of dysarthria and not a language disorder. The authors note that this is sometimes overlooked in the development of clinical speech disorder measures. The authors also note the easiness of administration for the DIP and the advantages of being a self-report measure, which gains insight on behalf of the individual with the acquired dysarthria and not the clinician. The greatest strength for this study is the progress it takes to develop the first measure to examine the psychosocial impact of acquired dysarthria, an area that has otherwise been void in the clinical field. There are several limitations to the current paper that inhibit the clinical use of the DIP in its current stages. One limitation is the restriction of generalisation for the psychometric results. Moreover, results are restricted to an Irish population and cross-cultural reference must be cautioned. Furthermore, participants are of a limited number and therefore larger sample sizes are required before generalisation can be inferred regarding the Irish population. A second limitation ties to generalisation and also concerns skewed results, whereby the authors deliberately sought participants whose therapists believed were aware of their dysarthria, yet were not concerned about it. If this particular subpopulation is to be analysed, then results must be limited to people with such an awareness of their dysarthria. Failure to recognise this participant characteristic can skew results concerning self-concept. The third limitation of the current paper is the existing ambiguity surrounding hypotheses and data analysis. The author stated no hypotheses or information concerning the methodology involved in data analysis. Thus, it is impossible for readers, researchers, and clinicians to know if data analysis was rightly undertaken. This raises the ethical issue of potential publishing bias of falsifying significant results. This is particularly indicative where authors report only statistically significant findings. However, note psychometric limitations in their discussion and concluding paragraphs. The authors conclude that the DIP shows great potential as a statistically sound measure for the psychosocial impact of acquired dysarthria. However, the scale requires development and refinement before it is suitable for clinical use in the treatment of dysarthria. There is a positive outlook for the future of the DIP. However, its developments and refinement should also include expanding to different populations, such as a larger sample of the Irish population, populations from other countries for cross-cultural use of the DIP, and across different subpopulations of people with dysarthria, such as those requiring assistive technologies. Working through these hurdles can see future implications for the use of the DIP in both clinical and research settings for understanding the psychosocial impact of dysarthria. That concludes my presentation today. Thank you for listening, and please refer to my reference list.